Welcome everyone to this new webinar on how to diagnose faults in a solar plant using patterns. So to be honest, I think this is one of the most exciting topics for the webinar that I was very much looking forward to, given this is like a topic that we are always being asked, like, okay, like how can we classify the faults just using data? So the aim of this webinar is really to discuss all together what is the methodology that we use, but let's make it a bit more interactive. So for those of you who don't know me, I am Maxine, and I'm one of the founding members of Smartelio, heading the partnerships. And yes, let's get started. So welcome everyone. I know that we have some friends coming from Switzerland where we sit, but so good afternoon to you. Good morning to our US friends, and good evening or good night for our friends in India or Asia. So before we get started, I was checking a bit like some jokes, and I feel that this one was pretty relevant to this topic. So I really wanted to pull this for the webinar. So the question is, what happens when we bring to the same room AI algorithms, data with a quality that sometimes can be doubt of, and also machine learning? Well, as a result, what you get are some results that you can be surprised of, and in worst case, that you cannot even understand. So this is what happens whenever you are using AI algorithms, data, but without physics behind. You cannot understand the results, and you cannot even understand how did you get the results. So this is really like a logic that we found whenever like we started our journey 10 years ago, that, okay, whatever we do using AI, it has to be physics informed. And our whole philosophy at Smartelio has started that way. And this is what we're going to show you a bit now. So some house rules, I think for those of you who are used to our webinar or any webinars in general, you should know that. But basically, if you have any questions or any comments, please feel free to directly type them in the Q&A section at the bottom of your screen. If anything goes wrong during the webinar, please try to refresh your browser and rejoin. And if you're interested in discussing more about this topic after the webinar, our team would be available and we'll share soon the link to book a call with us directly. So today I'm very excited to co-host this webinar with my colleague Shankaransh, who is our Chief Operating Officer and also the co-founder of Smartelio. Shankaransh, please show your face.
Hi, Maxine. Thanks. And of course, very interesting topic for today's webinar. And I'm always excited to share knowledge with industry colleagues, tell a few and learn a bit from them. So looking forward to it.
Actually, Shankaransh, I'm very happy that we get to discuss, the two of us, this topic, like how can we simply like use data in order to really identify the faults. And I know that this is something that you do like in your daily life, let's say, like really like checking how our software works and really like serving our customers. And for that, you really leverage your experience, like being like for how long? More than 15 years, an asset manager, especially like in the US. So yeah, I think the audience is also very much looking forward to your insights on that.
Okay. Yeah. No, it's been an exciting journey. See, when we started Smart Helio for about 8-10 years, I had industry experience, but after what we are doing in Smart Helio, now we are getting plans from different continents and more than 15-20 countries where we work in. So the use cases that I'm exposed to, I have learned a lot of physics after analyzing all the gigawatts that we do right now, and that has been a pretty exciting journey.
Great. So for this webinar's agenda, what to expect. So very briefly, we're going to remind you who is Smartelio and how do we work. But then we'll go into the fun parts about guess the pattern. So maybe some of you are already following us on LinkedIn. So if this is the case, then maybe you are familiar with our guess the pattern game, which happens every Tuesday. So we have like a pattern, then you have to guess what is the fault behind. The aim is really to show how our software works and try to challenge the software and see how whether you can be as fast as our software to identify the faults. And of course, we'll have a Q&A session. I know from our webinars, this is always the most exciting part. So we'll make sure to have enough time to address most of the questions. So for the game, how to play? That is very easy. First, you'll have a plot and you'll have to observe it, of course. And based on that, you have 4 options, out of which you need to guess what is the fault from the plot. So you'll just have a poll and you'll have to click which is the option according to you. And let's see at the end who is the winner of the game. But before we get started, let me just remind you a bit who we are at Smartelio and what we do. So Smartelio, we are the doctors of solar plants. So basically what we do is that we're going to diagnose why a plant is sick, but we're also going to prevent the plant from getting sick. So this is really on the predictive side. And based on that, based on the diagnostics and prediction, we're going to prescribe some actions to make sure that you're going to really maximize your energy output. Our aim at Smartelio is very simple. We aim to empower asset managers to prevent downtime, gain control back over your assets, but also cut O&M costs by almost like 80% through automation and of course through pattern recognition. So now we have over 6 gigawatts of assets under management, working with more than 100 clients across the world. So we are very international, and just like Shankaran said, and we have like 30 people working and very driven by our mission of making sure that any solar assets in the world should work well in the most profitable way as possible. A little bit about our foundation that would help you to understand how our software works and also like how come we took like this physics-informed AI approach. So we started more than 6 years ago in the market, but before that, we had a decade of research and development. So we were founded here in Switzerland as a spin-off of EPFL. And we also received a great R&D grant from the Swiss government. So we are very lucky to have such support at that time when it was still like very new topic. And as part of this R&D grant, we had access to more than 5 billion data points, which were labeled. And this is very important because what it means is that for each plant from where we had these data points, we had been told that, okay, like in that plant, in that specific section, in that specific day, this was the fault happening. And this is how you can see it on data. So based on that, we could study the physical behavior of various faults. So now we're able to classify more than 30 different types of faults, whether this is soiling, shading, vegetation, inverter level fault, etc. And each of these faults could be mapped to the unique signature on voltage and current. So thanks to our decade of R&D, we were able to develop these physics-based algorithms to not only classify losses, what you can see just behind me, but also to predict faults. And now let's get the game started. So this is the first pattern. Just to explain you how to read this. So first, this is like a plot that you're getting directly from our autopilot software. So basically how it works is that every fault that our software is able to classify is not going to be a black box. And that was something which was very key to us. We really want to provide full transparency. So for that, what you can do whenever you are in our software is that you can click on the fault and then there would be this diagnostics theater pop-up that opens. And there you can see the pattern. So this was the pattern that our system has identified. And now the aim of the game is to see whether you would have been able to identify as well. So this is the first pattern. What you can see is, so the blue dotted line is the irradiance. The orange curve shows the current of the faulty inverter. And the red curve shows the voltage. And all of that are DC side data. So now let me launch the first poll and let's see who are the ones who are able to identify which fault is it. So let's get it started. So we'll wait for around 20 seconds. So like that, you will get to see whether this plot is from vegetation growth, interval shading, inverter voltage issue, or ISO. Let's see. I know that we did not start with the easiest one, so I'm curious to see the results. Okay, 5 more seconds. Okay, now I'm ending the poll. And here are the results. Okay, that's interesting. So most of people believe this is an inverter voltage issue, and then it's between interval shading, vegetation growth. So interesting. Let's see, Shankaraj, what did the system identify? What was the correct answer?
Like you said, it's the first one and probably not the easiest. It is indeed a vegetation growth. Um, a lot of factors that goes behind. See, all the four are possible reasons. Yeah, and that's where patterns play a very big role. Here, what's happening is that there is a drop in voltage in the morning, which is pretty consistent. It can happen typically because of a reason that can occur every morning. It can be, I was actually expecting more of inter-row shading as the highest vote, because in the morning there's some shade on the modules which is instigating the bypass diodes, and it's dropping the voltage. Now, the peculiar part, why this is a vegetation growth, typically in vegetation growth, the pattern of shading is not uniform. Some part of the inverters would get more and some part would get less. And that would lead to multiple peaks in the power curve. So if you would see, for example, the second or the second last curve, you will see in the beginning there is a little bit of power spike. There are multiple power curves on the current. It's more visible if you go here, yeah, right at the beginning, and that's what makes it more peculiar to a vegetation growth pattern. Yeah, so
So we can actually see also here in the zoomed in picture.
yeah,
That's
so if
what
you
you're saying.
look at the beginning of the curve, so
Yeah.
multiple spikes while the voltage is low, and this would happen when there is uneven shading on the inverters. Yeah.
But Shankaraj, that's interesting. Like, why do you think that most people believe it was like an inverter voltage issue?
Which can happen if I'm only looking at the voltage, of course, in the morning, and it's also a signature of inverter startup voltage. Sometimes the startup voltage is starts creating issue, and it can have that pattern. But then what we are also tracking behind, there are multiple correlations that we are doing. Yeah, like I said, all the four answers could be correct, but the devil is in the detail. And the detail here is these multiple power spikes, that helps the software to classify it as vegetation growth and not inverter voltage issue or inter-row shading for that matter.
Got it. Thank you, Shankaraj. Okay, now next pattern. So you have the choice between disconnected strings, hard soiling, DC wire damage, and PV module damage. Now, one thing which is different from the previous pattern, now you see actually more curves. That is because what our system does is also taking as a benchmark the best inverter in the plant with the same configuration. So that is being shown by the green line. So this is the green line is the current from the best performing inverter. And the purple line is the voltage from that inverter. So I'll let you have a look at the plots. And the poll is going to be open soon. Okay, ready? Launching it. Okay, now you have 30 seconds. Let's see. Okay, 10 seconds more to go. Going to end the poll. The last one who want to vote. Okay, ending the poll now. Yeah, interesting. Showing the results. Now again, we see it's mostly between disconnected string and DC wire damage. So let's see what is the correct answer. PV
Interesting.
module damage. So, okay, again, we're not able to get it right from the audience. Shankaransh, how come is it PV module damage?
Well, okay, again, DC wire damage, I could expect that got a fair share of votes, but I was a little surprised with disconnected string. So if there is a disconnected string, I will lose current at least worth one string. Here, if you see the maximum amperage, the maximum current that even the best one is reaching at is around uh, what, a little over 6, 7 amperes, maybe 10 amperes. And the worst one is just right under it. Yeah. So it's definitely not a disconnected string. It very well could be a DC wire damage.
So people are not completely wrong, means.
Yeah,
Or
well,
it
yeah.
depends on the correlation.
Exactly.
Maybe we do.
DCY damages, for me, it would have been the next suspect. The reason being, if you look at the voltage, yeah. So the faulty one is the red one, and with wire damage, resistance increases in the circuit, and that will pull the voltage low. Typically, the voltage in the case of PV module damage, however, if a module is damaged instantaneously, I'm going to lose the VMPP of at least one module. Yeah. Now, with pattern, what you need to see is it's first of all, it's an irreversible damage. Yeah. I mean, if a panel has gone bad, it has gone bad. And then if you track the voltage at different environmental conditions, because the voltage would keep changing, but at every instance, if you get that difference of at least one module, it's easy to classify that as PV module damage. It has some complications as well. If within the same inverter, if there are multiple modules that have uh, bypass diode failures, yeah, and these are only partial diode failures within a module that can have 2 or 3, 4 bypass diodes. So multiple bypass diodes could also have a similar signature, but then almost all of them need to happen at the same time to create such a difference at once. Yeah. And someone has got to be very unlucky for that to happen. Uh, so yeah, that's why it's PV module damage.
Right, thank you. So moving on to the next pattern. So again, the 40 inverter, in that case, it's an MPPT. The 40 MPPT is going to be compared with the best performing MPPT. So the color coding is the same. So the best MPPT is going to be in the green and red for current and voltage. That is going to be compared with the 40 current in orange and 40 voltage in purple. Oh, sorry, in red. So let me open the poll while you look at the plots. And launching it now for the next 30 seconds. Let's see, so you have 4 options. Can it be inverter heating, data logger issue, MPPT issue, or even shading? Yeah, ending the poll. Oh, interesting. So most of people, so around like 50%, believe it's MPPT issue. Now let's
Uh,
see what is the answer here.
you know, I to me to me the previous two ones were relatively easy, and this was complex, and 50% answered it correctly. So indeed, it is an MPPT issue, and um, it's not very strongly visible here. But if you see there is continuous fluctuation in voltage, there's continuous fluctuation in the current. Now, just looking at it, it won't be sufficient. What you actually need to do is to be able to track that the inverter or the MPPT fails to settle at the global maxima, and it continuously fluctuates between the local maxima to find a point where it can be stable. But this inverter, for some reason, or this MPPT, for some reason, is not able to do that. Yeah, so very rightly so. Now, one more thing that I wanted to point out, that if such MPPT issues, which, see, at this level, it will cause barely any loss in energy. Yeah. Um, so if you are just tracking with your PR, your specific yield, your energy yield, such issues are extremely easy to miss. Yeah, unless you have a mechanism to track these in real time and understand what's happening with your MPPTs.
Yeah.
Because eventually, if such issues persist, that can create an imbalance either in the current or in the voltage. Yeah, and that would lead to an inverter shutdown. Yeah, might not be an inverter failure, but definitely an inverter shutdown, depending on how large that imbalance goes.
But Shankaransh, this sounds pretty simple, like the pattern that you have described, and the consequences are pretty significant. So why don't you think like everyone not have it already? You know, because MPPT issue is something that I know our software is able to identify as always like a early signature to inverter failure.
Right.
So how come like not everyone have it already?
Um, I wish I had an answer, and I'm also happy that everyone doesn't have it yet. No, I'm just kidding. But see, um, it becomes difficult to model, especially MPPTs, because a lot of different faults that happens on the DC side, MPPT is regulated. Something is lowering the current, something is lowering the voltage, and MPPT continuously tries to track and settle at a point where it gets it can extract the maximum power. Yeah. But then if someone is able to track that this is happening frequently without external factor, or even after separating the external factors, this condition exists. Yeah. In a PV plant, there cannot be just one fault. There are multiple faults. Yeah. So it will be the trick here is to be able to separate all the other issues that might lead to a response from MPPT that will alter the current and voltage, and then just only observe the behavior of the MPPT in isolation. So that's what gets a little complex here.
I see. Thank you, Shankaransh. I see that we're also getting questions. So please keep asking your questions, and we'll be able to address them during the Q&A session. So moving to the last pattern. So now you see again, so we have some options. So you get to decide whether this specific pattern, whether this is a data logger issue, grid issue, bad weather, or even inverter faults. So let me share the poll. Launch it. Now again, we have 30 seconds. Let's see who gets it right. Yeah, I see there are mostly like 3 faults where people are hesitating between. Okay, 5 more seconds. Okay, I'm ending the poll now. And here are the results. Okay, so most people believe it's inverter fault, but then there's also bad weather or grid issue, which could be possible reasons. So let's see, Shankar, what did the system say about that?
Well, the audience is surprising me. It's like the level of difficulty it's getting easier for people. So indeed, it's an inverter fault. Bad weather, we put that as an option because That's the most confusing option. So of course, there's bad weather. We can see the good and the bad inverters, especially on the current side, because with irradiance, current has a direct relationship. So both are fluctuating. Yeah, both are responding the same way to the irradiance. But then, Maxine, if you could point out at the third curve, the on the current, see the orange color, it dips. Yeah, and then it goes into a VOC. At the time the current goes to zero, the voltage opens. It is open even the next day, and then the inverter starts functioning again. But then it has more unusual dips than the better performing inverter. And eventually, again, after 3 or 4 days, it goes into an open circuit condition. It shuts down. A couple of things are extremely important here. First, in bad weather, inverters shutting down could be because of very low irradiance. But if I'm able to build correlations with other inverters having the same configuration, and if I'm able to establish the fact that other inverters are working and this is not, that's first red flag for me.
Mm.
Um, Again, it's a very common phenomena for inverters to shut down in really bad weather or low irradiance conditions, that even such conditions can go unnoticed. Yeah. Or as an asset manager, I might not bother myself as much, given that the weather is already bad,
Yeah.
unless I knew that this is a pattern. If I was able to build correlations with other inverters and also able to predict that this pattern might repeat, that will cause me concerns. Yeah. And that's where it gets tricky. It becomes difficult without using certain technologies to predict that such pattern would repeat. Yeah. Now, these kind of fluctuations typically, see, in inverters, there are 100 things that can happen. But typically, such response in current and voltage would come because there's some issue with IGBT or the power switching, it fails, or the cooling mechanism, it's not working as efficiently. Um, to classify the root cause of such inverter faults, it is also difficult. Yeah, truth be told, unless I have some more data, for example, inverter cabinet temperature data, or the CPU data from the inverter. So then we can tell what the root cause could be leading to such inverter behavior. But
Mm.
at least as long as we are able to predict that such an inverter behavior, that it shuts down and comes back up, it's going to repeat, I can at least get an alert that, okay, there is an inverter fault. There's something happening with the inverter. And then if I'm not able to collect other data from the inverters, I can go and physically inspect. Yeah. And I, as an asset manager, or asset managers who are our friends, they would typically go when they know that, okay, there's an inverter fault and it's going to repeat. Yeah. And irrespective, if I'm able to predict that, irrespective whether it's a bad weather or good weather, this pattern would repeat. Yeah. That ensures that there is something happening with the inverter. Yeah.
Because actually, Shankara, that's a very good point. I was about to ask, isn't it like this kind of faults, you can anyway get them from SCADA or even like monitoring platforms. But then like your point about the prediction, the fact that not only we understand that this is happening, which is something a bit obvious, let's say, but the intelligence here that it seems we're bringing is more in terms of, okay, like what's going to happen in the past. So we can really help from preventing it eventually, not waiting for it to happen or did it failed, then you can go and fix, okay, this is easy. But at the end of the game, at the end of the day, here is really to prevent it from happening another time. So prediction is key indeed. Perfect. And now let's go to our last but not least pattern. So this time you have the choice between module defects, degradation and morning shades, hot soiling and riso. Let me launch the poll. Launching now. So let's see. For the last pattern, are we going to get a winner? Okay, there is one fault which seems to get the most votes. Okay, 5 more seconds to go. Okay, I'm ending the poll now. What was the answer? Share results first. Okay, so most people believe this is a plot for degradation and morning shade. So that's interesting. We have like 2 faults impacting the same MPPT in this case. Then we also have like a RISO, which is a possible fault to the audience. So let's see, what is the answer here for the last pattern, Shankransh?
Um, of course, it's degradation and morning shade. Reso um, could be a pattern, but typically when the resistance isolation threshold is breached, inverter goes into a partial shutdown or shutdown condition. And typically, in most of the cases, we see the current almost touching zero and the voltage approaching VOC. If the reso is low, we can get a pattern like this. Um, this was again a tough one. In my opinion, if I take a wild guess, adding degradation and morning shade together was probably the trick that made it a little easy. Because the pattern of degradation, module degradation in this case, is more on the current side rather than on the voltage side. So what happens is as your modules get degraded, um, see, if in isolation, if you test the modules, you would probably see a signature on voltage, but it it's it exhibits a different pattern when it's connected to an inverter because the MPPT comes into play. Yeah, and MPPT tries to shift the power curve to extract the maximum power. And in most of the cases, when the voltage goes down a little bit, it tries to pump it up, and we see some signature on the current side when it's degradation. Now, degradation is a very slow pattern. So it becomes very difficult if even if you show me an IV curve, Maxine, even for a month, 2 months, I won't be able to tell. Yeah.
Yeah.
What's important is that if there is degradation, it's going to be irreversible reduction in the power. And if we are able to track that at different irradiation values over the time, my power is reducing slowly, yeah, then I can be sure that there is module degradation. Again, it is complex because almost all the sites across the world have soiling. There could be other issues that is leading to reduced current. So if I am able to somehow identify signals coming from these multiple different kind of faults that can impact the current, if I'm able to identify and separate them, yeah, I can
Yeah.
tell that module degradation is happening. And that's where I think advanced technologies nowadays are playing a role.
Yeah, because to follow up on that point, Shankransh, you're mentioning about okay, like what happens in case that one input, let's say like one MPPT or one inverter, is being impacted by several faults. To decouple these faults from each other, so in that case, for example, what is the ratio of machine learning that is needed, like to detect and to decouple faults so it can have at the end a very clear pattern despite all the noises that we're getting?
Right, right. No, that's a good question, Maxine. I think it's a combination of both. Um, I would definitely say that there is 70-30, 80-20 mix of physics and AI. If there are more signals, we need more advanced technology than simply using physics. Yeah. Physics helps us to identify different kind of signals, but then it is the AI that can help to separate them and even help us to quantify the losses coming from a particular signal, which physics might not be able to do it more accurately. Yeah. So I think it's identification, separation of signals, and being able to quantify the loss coming from each signal is where AI plays a bigger role than really trying to identify if this is degradation. That's mostly physics. Yeah.
Got it. Thank you, Shokransh. So now the game is over, so we can go to the questions. We have received quite a lot of questions. So in case we're not able to answer to all of them, what will happen is that along with the webinar recording and the slides, we will also have a document where we're going to consolidate all of the answers to the questions that were answered during the webinar that could not be answered. But maybe you can start already. So we received quite a lot of questions regarding the data. So two aspects on those questions. The first one would be, okay, like your data quality was not good. Okay, so in case the data quality is not good, can we still identify the patterns? So this is the first question. And then there's another question from Gabe Cook, who is asking, what frequency are these data logged at?
Oh, both good questions. I think the first question we get quite often. See, if the data is bad, it's a bad start to begin with. Yeah. Now, if the data is bad, can a technology like ours or similar technology, can't we not do anything? No, we can still do something. See, there are two parts to the problem, how these problems are classified. First, an anomaly is detected. Yeah. If the data is bad, let's say it's missing and all of that, we can first clean the data as much as possible so that we know that at least the data that we have, it's in the range, it's in the expected range. Yeah. If I have two strings and the current is 100 amperes, I mean, I just simply need to drop the current. But as long as the data is in range, I can at least detect the anomaly in the data. Now, if data quality is poor, this is the impact that it will have. One might not be able to do the accurate classification. Yeah, I can still alert that there is a problem, but the accuracy of classification, whether it is soiling or shading or vegetation or a bird poop or an MPPT fault, that would be impacted. And maybe just to add to that, the approach that we take as Smart Helio is, in such cases we assign probabilities. Yeah, that okay, given the state of your data, there could be these four kind of issues, and these are possibility of each kind of issue. So that at least when you go to the site, if it's not one problem, you have other options that you can go to the site and check.
Yeah. Another question again on the data. This one is about how long do you need data? So we have a question. I have a new plan, but it's not performing well. I only have 2 months of data. Does your software help us? 2 months of data, what can we do with that? Tell us.
One part of the question that we missed from the previous part is was the frequency of the data.
Yes.
For our solution, we take at a maximum time interval of 15 minutes. Beyond that, there's some hallucinations, some inaccuracies, but as long as your timestamps are within 15 minutes, the solution works. It's good. Now on the second part, I only have 2 months of data and it's a new plan. Well, even if you have just 1 week of data, our solution is going to work. Not everything is going to work. There are certain things, for example, module degradation, that naturally just because of the nature of the fault, it will take longer period.
Yes.
But that's also the beauty of the solution, that since it is based on physics, I don't need a large amount of data to train my models. Yeah. So even if the plant is 1 day old, and if there is a reso fault, if there is an MPPT issue, I can detect it right away. If your plant is this new, 2 months old, you should expect two kind of problems. most likely there are issues coming because of poor installation or poor design or poor equipment. Yeah. Um, so yeah, I mean, I'm sorry to hear that, but yeah, I mean, we can help if there are issues. I'm pretty confident that we should be able to help there.
Well, Shankaran, still on the same topic, we're getting questions like, okay, like how long of historical data do we need in order to recognize pattern like soiling, degradation, or even accelerated degradation? Now, since you've already answered that, okay, even within day one, since it's really based on physics, we anyway recognize the pattern. But perhaps I can just turn a little bit the question in how long of historical data do we need to quantify those losses? Like whether it's quantify the soiling losses or quantify the degradation.
Uh, Maxine, okay, I'm back. So look, I would not say that historical data doesn't help, even in classification. Yeah. Um, like I said, there are certain issues that does need a longer duration of data. Let's talk about soiling. Yeah. If you give us historical data, it does help because then I can establish certain trends that whenever it rained and it was enough rain to cause a cleaning impact, then those could be my benchmarks to measure the soiling rate. And then even with 1 month of live data, I would be faster and more accurately able to tell you that that there is soiling. So I would say that depending on the nature of the fault, typically the slower faults like soiling, like degradation, um, historical data could be helpful, and anywhere between 6 months to sometimes even 1 year if the rate of impact of that fault is very slow. Sometimes even 1 year of data could be very, very helpful. And to your point, Maxon, to the quantification, yes, historical data helps to establish trends. It helps our models to gain the knowledge that in a similar um, weather condition with this kind of performance, what to expect. Yeah. And the benchmark of that expected power really helps us to quantify the losses better.
Thank you, Shankaran. Now I'm seeing still many questions are happening, and I know that we are running a bit out of time, so I'm trying to see which are the ones who are coming the most often.
Maybe we can take one more, and then early next week we can reply to the next.
So one question coming from Harsh Chaturvedi. I think data accuracy through SCADA is a major issue. When we try to identify lost waterfall, what are your suggestions to overcome this issue? Very good question.
Um, See, if the data quality issue is because of issues with some communication protocols, because of some connectivity, then we do have an option to fill those data gaps. Yeah. It's not always the most accurate, but over time we have been able to train our machine learning models to get to some accuracy. Yeah. Um, so that's one. Now, the other aspect is a lot of these SCADA systems or communication protocols or monitoring systems also do some level of data aggregation. Yeah. Um, if the data aggregation is bad, it makes it very difficult um, to work with that data. To be very honest, what can be done though? At this point, um, as long as you know that given the irradiance, I mean, first you need to make sure that even the irradiance data is correct. But let's say I've figured that out. So as long as I have a good irradiance data, I can understand based on the metadata, based on the kind of inverters and modules used and the array configuration, all of that, what is my expected value? And then I can make some corrections to the data. But yes, at the end of the day, we need to treat the data. I would say that if the problem is at source, especially because of communication protocols or aggregation logics, it becomes more difficult. But if there is missing data, it's relatively easy to work with that data. Um, Also, it does make it a little difficult to have a very good waterfall diagram with a bad data. And like I had mentioned previously, that in such cases, what's important is at least how soon can we help you get to the problem? Yeah, that at location X, this is the pattern that I see, and the issue could be A, B, C, D, you know. So with a bad quality data, that's the best that we can do.
Thanks, Shankar. And now the last question. I'm sorry, like we're getting lots of very interesting questions, so don't worry, we'll get back to you with the answers of each of one questions. And even after the webinar, if you have even more questions coming, please feel free to reach out. There's one question in particular that is interesting and that a point we haven't touched yet. It's about new technologies. So how big a range of PV plants have your models been trained on? Does it cope well with inverter models, PV panels, which I've not seen before? And maybe I'm going to expand this question to any new technologies that now we have like 6 gigawatts under management. Of course, we have like different technologies across the globe. But how does our pattern recognition methodology can cope with these new technologies coming up every day?
Mm. No, that's a very, very good question. It reminds me of a situation that we had, I think last year, when we started getting a lot of plants from our clients with bifacial modules. Yeah. With technology, the algorithms have to evolve, and that's one very good thing. See the even within inverters, how inverters became transformerless, and then so many innovations happened in the cooling technology, in IGBTs, and our algorithms had to evolve with them. When we were doing bifacial, in fact, we also work with a lot of OEMs, so we had to do workshops with our OEM friends to understand the physics and how a bifacial module would react in different environmental conditions. Yeah. Or if in the same condition, a bifacial and a monofacial module is put, what's the difference that we should expect? And then the models had to be adopted to that. Um, so that's one. The other thing that I would say is our models, since they're based on physics, they are not make and model, they are make and model agnostic. If I have algorithms or models that can work on bifacial modules, it will work on bifacial modules of Q cells, it will work on bifacial modules of Trina. Yeah. If I have an IGBT failure detection or failure prediction, it will work on a Huawei inverter, a Schneider inverter, and an SMA inverter as well. Yeah. So that's the beauty of working with first principles of physics. You know, that's not going to change. But yeah, surely there are adaptations with technology.
Great. Thank you, Shankaransh, and thank you also for all of the questions from the audience. Now I think the time is up, but again, no worries, we'll get back with even more answers. So before we finish, we just wanted to let you know that we have a special discount for whoever has attended to the webinar. So if you want to try yourself our pattern recognition methodology, so for the diagnostics of a plant, which is maybe like underperforming, I think most of us has this kind of thing in our portfolio. So in case you are really curious to uncover the unknown losses from such plants, we have this discount. So normally we charge like 300 euros per megawatt, plus inbounding costs. And this time we have like 150 euros per megawatt, and the onboarding costs are also free. And this discount is valid until mid-February. So yeah, feel free to reach out in case you'd be interested in learning more about our technology. And again, thanks a lot for your attendance. I think we received lots of good questions, so it really shows that this topic is a very hot one in the industry. We'd love to talk more. We'd love also like to exchange how you work also. So please feel free to reach out. Our experts and the team is always happy to share insights. And yeah, again, you'll receive the email with access to the recording, webinar slides, and Q&A list. So hang tight. And until then, have a nice evening, everyone, or have a nice day, wherever you are. Thank you very much. And thank you, Shankaransh.
Thank you, Maxine, and thanks everyone. Take care. Bye.